from a small supermarket trolley to huge power plants. A great number of light duty as well as industrial equipment would not function without the use of bearings in some form. Bearings are crucial tribological components of many types of machinery and exist in a variety of forms and shapes. They can be defined as components that support only a specific type of motion in a system that may be under static or dynamic loading. What is the purpose of bearings? The main purpose of bearing is to prevent direct metal-to-metal contact between two elements that are in relative motion. This prevents friction, heat generation, and ultimately the wear and tear parts. It also reduces energy consumption as sliding motion is replaced with low friction rolling. They also transmit the load of the rotating element to the housing. This load may be radial, axial, or combination of both. There are different types of bearings, including plain, ball, roller, fluid, and magnetic. Number 1. Rolling element bearings. Rolling element bearings contain rolling elements in the shape of balls or cylinder. We know that it is easier to roll a wheel than slide it on the ground, as the magnitude of rolling friction is lower than sliding friction. The same principle is in the work air. Rolling element bearings are used to facilitate the free movement of parts in rotational motion. Even when we need linear motion in applications, it is easy to convert rotational motion to sliding motion. Consider an escalator or conveyor. Even though the motion is linear, it is powered by rollers that are driven by motors. Number 2. Ball bearings. Ball bearings are probably the most common type of bearings. They are found in everything from inline skates to arc drives. These bearings can handle both radial and thrust loads and are usually found in applications where the loads are relatively small. Ball bearings provides very low friction during rolling but have limited load carrying capacity. This is because of the small area of contact between the balls and the races. They can support axial loads in two directions besides radial loads. Ball bearings are used for controlling oscillatory and rotational motion. For example, in electrical motors where the shaft is free to rotate but the motor housing is not. Ball bearings are used to connect the shaft to the motor housing. Advantages of using ball bearings. Ball bearings are good wear resistance. They do not need much lubrication. They provide very low friction. They have a long service life and easy to replace. They are very cheap to buy and can handle thrust loads. Disadvantages of ball bearings. They may break due to shocks, can be quite loud, cannot handle large weight. Type number 3. Plain bearings. A plain bearing is the simplest type of bearing. It usually only consists of a bearing surface. There are no rolling elements in plain bearings. Plain bearings are used for rotational, sliding, reciprocating, or oscillatory motion. The bearing remains fixed while the journal slides on the bearing's inner surface. Type number 4. Fluid bearings. Fluid bearings are designed to take the load off of moving parts while also reducing friction. But unlike the other bearings previously mentioned, they don't contain moving balls or rolling elements. Instead, they contain liquid between the fluid creates a thin layer to which the moving part is exposed, allowing it to bear the load. Most fluid bearings contain water or oil, both of which are effective at reducing friction. Type number 5. Magnetic bearings. In addition to fluid bearings, magnetic bearings are another unique alternative to traditional rolling style bearings. Featuring powerful magnets, they use magnetism to lift and bear loads without creating direct contacts. Magnetic bearings literally levitate moving parts into the air, allowing for little or no friction. Of course, they only work when used in conjunction with ferromagnetic metals.